Hello everyone, this is part 1 video on past year NEET questions from the topic Chemical Kinetics. We'll start with a question that has come in the NEET 2019 year. If the rate constant of a first order reaction is K, then the time T required for completion of 99% of the reaction is given by. So we need to express the time that is required for 99% completion of the reaction. So if the reaction is completing by 99%, that would mean if A0 is the initial concentration, then 99% is completed means 1% will be the remaining. So the concentration at the particular time t will be equal to 1 by 100 into A0. Now if you look at the first order rate expression, K will be equal to 2.303 by T log of A0 by A at the time T. Now in this we have A at the time T will be equal to A0 by 100, and on substituting it, what we would be having is K will be equal to 2.303 by T into log of A0 by 100. A0 and is cancelled, so 100 will go to the numerator. So what we have is 2.303. On the LHS we have K will be 2.303 divided by T into log 100. Now log 100 will be 2, so K will be equal to 2.303 into 2 divided by T. 2.303 into 2 will be 4.606. Now the T is what we are looking for, so on rearranging, T value will be equal to 4.606 divided by K. So this is the time required for 99% completion of the reaction. So the correct answer is option D. Next we'll look at the question that has come again in the year 2019. For the chemical reaction N2 gas plus 3 moles of H2 gives rise to 2 moles of NH3. The correct option is, so here if you look at these options, they are talking about the relation between rate of consumption of the reactants and rate of formation of the products. So as per the relation between the rate of consumption of reactants and rate of formation of product, for the reactants the rate of consumption divided by the stoichiometric coefficient will be equal to the rate of formation of products divided by the respective stoichiometric coefficients. This is the relation between the rate of consumption of reactants and rate of formation of products, and this value will be equal to the unit rate, which is what we will be measuring as the rate of a reaction. So if you look at the given reaction, what we have is N2 gas plus 3H2 gas gives rise to 2NH3 gas. Here the stoichiometric coefficient is 1, here it is 3, here it is 2. So what we will be having is minus dN2 by dt. This is the rate of consumption of nitrogen. The stoichiometric coefficient is 1, will be equal to minus dH2 by dt 1 by 3 will be equal to 1 by 2 into dNH3 by dt. So we will not have a minus for ammonia because it is the product that is going to be getting formed. So the concentration of the reactants will be decreasing with time. That is the reason why when we say rate of consumption of reactant, we are using a minus sign. For the rate of formation of product, the value is simply going to be change in concentration by the time taken. There will be no minus sign over here. So if you see the options that will suit is option D, we can clearly see that minus dN2 by dt will be equal to half of dNH3 by dt. So the correct relation is option D. Next we look at the question that has come in the Odisha paper 2019. A first order reaction has rate constant of 2.303 into 10 power minus 3 second inverse. Now remember, we can conclude whether the reaction is first order or not by looking at the unit of the rate constant. So the unit of the rate constant for a first order reaction will not have any concentration term. It will be having a unit of time inverse. Now the time required for 40 grams of the reactant to reduce to 10 grams. So here what we have to assume is that initial concentration is 40 and final concentration is 10. We need to find what is the time taken for this change. And here there is an extra information given to us, that is log 2 value will be equal to 0.3010. So usually when we are solving these problems, since for the first order rate expression we have the logarithm term, we generally use these values: log 2 value 0.301 and log 3 value 0.477. Even if some problem it is not given, it's good to remember these values so that we will be able to approach the numericals fast. Now coming back to this question, what we have is the first order rate expression, K is equal to 2.303 by T into log of A naught by A at the time T. So here A naught value is 40 and A at the time T will be 10 grams. We are looking to find what is the value of the T. K is given as 2.303 into 10 power minus 3 second inverse. So on substituting K value, LHS we have 2.303 into 10 power minus 3 is equal to RHS 2.303 by T into log of 40 by 10. So 2.303 will be cancelled and log 4. So on rewriting it, what we have is T will be equal to, so the 10 power minus 3 will come to the denominator, 1 by 10 power minus 3. Log 4 can be written as log of 2 square. And this log of 2 square can also be written as 2 times log 2. So 2 times log 2 divided by 10 power minus 3, and log 2 value is 0.3010. So 2 into 0.3010 will be 0.602 divided by, we have 10 power minus 3. So when it goes to the numerator it becomes 10 power 3. So 0.602 into 10 power 3 will be 602. And since the rate constant is in units of second inverse, the T value will be coming in seconds. So the time required for the concentration to change from 40 grams to 10 grams will be 602 seconds. Option D is the correct answer. Now we can see a lot of questions are coming based on the integrated rate expression of the first order chemical reaction. Next we have another question that has come in the same Odisha paper 2019. This is a question based on the Arrhenius equation of the dependency of the rate constant value on the temperature. For a reaction, the activation energy value is given as 0. So generally we use the symbol EA, the value is given as 0, and rate constant at 200 Kelvin is 1.6 into 10 power 6 second inverse. The rate constant at 400 Kelvin will be, we are asked to use the value of R as 8.314 joule per Kelvin per mole. So here if you look at the Arrhenius equation for the relation between rate constant and temperature, what we have is log of K2 by K1. K2 is the constant value at temperature T2, K1 is the value at temperature T1, EA by 2.303 R into 1 by T1 minus 1 by T2. This can also be written as by taking the LCM 2.303 R T2 minus T1 by T1 T2. So this is the Arrhenius equation for the relation of rate constant on temperature. So we are going to be using this particular formula to solve this question. So here the temperature 200 Kelvin, the rate constant is given. We need to find rate constant at the 400 Kelvin, and EA value is given. So if you look at this Arrhenius expression, what we have is log of K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T2 T1. Now in this the K1 value we'll take it as the rate constant at temperature 200 Kelvin, 1.6 into 10 power 6. So on substituting it, what we have is log of K2 by K1 is equal to, now in the RHS side we can see that EA value is given as 0. So the entire RHS is now going to become 0. So log of K2 by K1 value we are taking it as 1.6 in 10 power 6 is equal to 0. Now logarithm of any term, if it is 0, means the term inside the logarithm must be equal to 1. Means K2 by 1.6 in 10 power 6 should be equal to 1. This would mean K2 will be equal to 1.6 into 10 power 6. So the correct answer is option B. So this concludes that if for any reaction activation energy is 0, this would imply that K will not have any relation to the temperature. K will not be depending upon the temperature value. Next we have a theoretical question that has come in the NEET 2018 paper. The correct difference between first and second order reactions is, so we need to conclude which of the following. So they given basically 4 statements and we need to identify which of them is actually correct difference between the first order and second order reaction. We'll go through the options. Option A is saying that rate of first order reaction does not depend on the reactant concentrations. Rate of second order reaction does depend on the reactant concentration. This is not correct. Why? Because the rate of first order reaction will be proportional to concentration power 1 and rate of second order reaction will be proportional to concentration power 2. In both the cases it depends on the concentration. In fact, if you look at option D is saying that the rate of first order reaction does depend on the reactant concentration and the rate of the second order reaction does not depend on the reactant concentration. This is also incorrect because for the first order rate is proportional to concentration power 1, second order rate is proportional to concentration power 2. Now coming to the option B is saying that half-life of first order reaction does not depend on the A0 value. A0 value basically means initial concentration, and half-life of second order reaction does depend on A0 value. So in fact, if you look at for the first order reaction, T half will be equal to 0.693 by K. It will not depend on the initial concentration. Whereas for a second order reaction, so just to give you some understanding of the second order rate expression, second order rate expression will be equal to 1 by A minus 1 by A0 is equal to KT. This is the second order rate expression. So here when we look at the half-life, we are looking at A being equal to A0 by 2. That means the 2 will go to the numerator. This implies 2 by A0 minus 1 by A0 is equal to KT. That means 1 by A0 is equal to KT. So T will be equal to 1 by K into A0. So this is the T half basically. So we see that the T half is depending on the A0 value. So only for the first order reaction T half does not depend on the A0 value. So this is the correct difference between the first order reaction and the second order reaction. We can look at option C also. Option C is saying that the first order reaction can be catalyzed, a second order reaction cannot be catalyzed. No, this is incorrect. Why? Because the catalysis is a process where we speed up the rate of the reaction. It can be there for any reaction, whether it is the first order or the second order. Next we have another question related to the half-life. This has come again in the NEET 2018 paper. When initial concentration of reactant is doubled, the half-life period of a zero order reaction is. So if you look at a zero order reaction, the rate equation is A0 minus A is equal to KT. This is the rate equation for the zero order reaction. So half-life would mean A being equal to A0 by 2. Means overall LHS will be a naught minus a naught by 2 will be equal to a naught by 2 is equal to kt. This is the t half value. That means t half value will be equal to a naught by 2k. So for the zero order reaction, we'll see that t half is simply proportional to a naught value. So since the t half is proportional to the a naught value, what we see is when a naught is doubled, the initial concentration is doubled. That's what is the statement of the question. Then what should happen is the t half also must get doubled. So the correct answer is option B. In fact, for any general order reaction, because we are seeing the zero order, first order and second order, the t half value will be proportional to a naught power 1 minus n, where n will be the order. So which means for the zero order it will be proportional to a naught. For the first order, since n is equal to 1, it will be independent of the a naught. And for the second order, if you put n is equal to 2, what we see that is it will be proportional to a naught power minus 1 or 1 by a naught. And this expression can be used to find out the dependency of t half on the a naught value or the initial concentration for any general order reaction for a single reactant. Next we have a question, again theoretical question based on the order of the reaction. This is the question that has come in the NEET 2017 paper. The mechanism of a hypothetical reaction. So the hypothetical reaction is x2 plus y2 gives rise to 2xy. In this x2 and y2 are the reactants. So they have given the mechanism in 3 steps. First step is x2 breaking down to give 2x atoms. That's a fast step. Second step is x atom combining with y2 to give xy and y atom. This is the slow step. Third step is x atom plus y atom giving rise to xy. This is the fast step. Now for any complex reaction, the overall rate will depend on the slowest step. So here the slowest step will be also called as the rate determining step. So the rate determining step here is x plus y2 giving rise to xy plus y. In this the reactants are x and y2, but x is not the original reactant, it is in fact the intermediate. Now we have to express the concentration of x in terms of the original substance, which is x2. If you look at the first reaction, which is of course a fast one, 1 mole or 1 molecule of x2 is giving 2 units of x. Means what we can understand here is the concentration of x will be equal to half of the concentration of x2. And when we substitute this in the rate determining step, what we have is half of x2 plus y2 will give rise to products. Now if you write the rate expression for this, what we'll have is rate will be proportional to x2 power half, since the coefficient here is half, and y2 power 1. So for this when we talk about the overall order of the reaction, the power here is half and the power here is 1. So the total order will be half plus 1, which is going to be 1.5. So the correct answer is option C. Next we have a question that has come in the NEET 2017 paper. A first order reaction has specific reaction rate. So specific reaction rate is also called as rate constant. The value is 10 power minus 2 second inverse. How much time will it take for 20 grams of the reactant to reduce to 5 grams? So here we have to take the initial amount to be 20 grams and final amount to be 5 grams. It's a straight question based on the use of the first order rate expression. First order rate expression is K is equal to 2.303 by T log of A naught by AT. So A naught value we will take it as here 20 grams and AT value will be equal to 5 grams. So K is also given to us. We just have to substitute and get the value of T. So from here K is given as 10 power minus 2 will be equal to 2.303 by T into log of 20 by 5. So 5 ones are 5 fours are log 4. So log 4 value will be 0.602 because log 4 will be 2 times log 2, and log 2 value is 0.301. In one of the previous problems also we discussed that it will be always good to remember these log 2 and log 3 values. So log 4 will be 0.602. So what we have is LHS 10 power minus 2 is equal to 2.303 into 0.602 divided by t. So we are looking for the t value, so that means t will be equal to 2.303 into 0.602 divided by 10 power minus 2. On simplification we will get the answer as 138.6 seconds. It's a straight question based on the use of the first order rate expression. Next we have another theoretical question based on the order of the reaction. It's a question that has come in the NEET second paper 2016. The decomposition of phosphine PH3 on tungsten at low pressure is a first order reaction. It is because, in fact this question can be made more descriptive by saying that at high pressures the reaction actually becomes zero order. Means it does not depend on the overall concentration of the phosphine. Why? Because if you look at the tungsten filament at low pressure, the concentration of the phosphine on the tungsten filament surface will be limited, and we see that the rate is proportional to the surface area that is covered. And at low pressure, since not all the surface area is covered, we will see that it will be a first order reaction. And at high pressure, since all the surface area is being covered, we will see that the order becomes zero order. It will not be depending anymore on the concentration of the phosphine. So the correct answer is that the rate is proportional to the surface coverage. Next we have a question that has come in the NEET paper 1 2016. The rate of first order reaction is 0.04 mole per liter per second at 10 seconds. At the time, let's say we're talking about the time t1 as 10 seconds. At this particular time the rate value is given as 0.04, and at the time t2, which is 20 seconds, the rate is given as 0.03. Now we know that the rate at any particular stage will be equal to K into the concentration at the particular time or particular stage, because we are talking about the first order reaction. So here basically what we need to find is the half-life period of the reaction. So how we can find the half-life is, from the integrated rate expression we can find the value of K, and once we get the value of K we can find the T half, because T half will be 0.693 by K. So if you look at it here, what we have is rate at T1 will be equal to K into A1, and rate at T2, we call it as rate 2, will be equal to K into A2. So if we are looking at in the rate expression, the ratio of say for example A1 by A2 ratio, that will be equal to rate 1 by rate 2. So we can use this relation to find the value of K from the integrated rate expression, and then we can find the T half. So let us look at this. So the first order reaction rate expression is K is equal to 2.303 divided by time. So time difference between the two stages is T2 minus T1, 20 minus 10 it will be equal into log of A1 by A2. So A1 is the initial concentration at the first interval 10 seconds, and A2 is the final concentration at 20 seconds. So here what we already discussed is we can write the A1 by A2 ratio as rate at the first interval to the rate at the second interval ratio, because rate is proportional to the concentration, and that would mean K value will be equal to 2.303 divided by 20 minus 10, which will be of course 10, log of 0.04 by 0.03. So this, on multiplying by 100, what we have is log of 4 by 3. So on simplification what we'll have is the value of K will be 0.0287 second inverse. Now this does require some amount of calculation, but once we simplify it, we'll get the answer as 0.0287 second inverse. So we can look at it. So k value will be 2.303 by 10. Log 4 by 3 can be written as log 4 minus log 3, and log 4 will be 0.602, log 3 will be 0.477. We'll simplify this subtraction and then multiply by 2.303, then divide by 10. That gives us the value as 0.0287. And once we get the value of k, the t half value will be 0.693 by k, means 0.693 by 0.0287. So this will be approximately 24.14 seconds. So the half-life of this first order reaction will be nearly 24.1 seconds. So the correct answer is option C.